Okay, today's topic is direct variation. Okay, direct variation, let's just work first off of the definition. So for direct variation, we have a function. So a direct variation is a function in the form y equals kx, where k does not equal 0. Okay? So a direct variation is a function in the form of y equals kx, where k does not equal 0. Of course, obviously, if k equals 0, then y would equal 0. And so really you have a point, and there's nothing more you can do with that. So k is equal to the constant of variation. So k, I've really written that badly, k is the constant of variation in a direct variation. And it is also the coefficient of x. Okay, so when we look at direct variation, what this is actually saying is that x varies directly with y. Oh, I was going to put with y. Okay, so what does that mean? Well, that means if x is increasing, y is increasing, and it is increasing at a constant rate. Okay, so it doesn't, go up a little bit and then go up a little, then double it, or it's always going to go up the same amount. So you are going to have a straight line just going completely and it's going to be constant variation. It's so much easier to look at. So first of all, let's just talk about is an equation direct variation. So let's just look at some of our equations. Let's say we've got 7y equals 2x. Okay, now we have to put this into y equals kx form, so that means that we've got to get y alone. So all we have to do there is divide both sides by 7, and that gives us y equal to 2/7 x. Okay, so in this case, this is a direct variation. So yes, it is direct variation, and k is our 2/7. 2/7 is our constant of variation. So that's our first one. Let's look at 3y plus 4x equals 8. Okay? Now, we've once again got to get the y alone, so I've got to move the 4x. So I've got 3y plus 4x, is equal to negative 4x plus 8. Really wrote that badly, and I do apologize. And then I've got to divide everything by 3. So that gives me y equal to negative 4 over 3x plus 8 over 3. Well, here's the deal. See this guy here? This guy tells me that this is not a direct variation. Okay? I can't have that in a direct variation. So anytime you've got something being added on like that or subtracted out, you do not have a direct variation. So in simpler terms, what I like to look at always is, you know, we have these equations, and quite simply, if you don't just have that y equals kx, if you've got anything outside of that, it's not going to work. So if I have y equals 7.5x, oh boy, already messed that one up. So here, let's start again. Y minus 7.5x equals 0, and I move my 7.5x to get it away from my y, plus 7.5x. So I'm doing it to both sides. Now I do have y equal to 7.5x. This is a direct variation, and k is 7.5, my constant. Okay? So it always follows the same form. Now let's look at writing a direct variation if you are given a specific point. So let's say I am given a point -3, -6. So my point is -3, -6. So all I'm going to do is I'm going to put, I'm going to take my y equals kx. My x is -3, my y is -6, that's a given. So I've got -6 equals k times -3. The way that we separate multiplication is with division. So I will divide out -3 to both sides. That will cancel it out on this side, and k will be equal to -6 divided by a -3 is a +2. So now I know what k is, and now I'm going to write my direct variation equation. So y is equal to 2x. Okay? So this is the equation I'm looking for. This is my k, and all I had to do was substitute those points. Okay? So that is a little bit about direct variation. Now let's just look at if we have tables rather than equations or points, do we have direct variation? So let's look at a table that, let me draw another table. I know you love watching me draw these tables. They're so beautiful. So I've got x and y, and I've got -2, 1, and 4, and I've got 3.2, and I've got 2.4, and I've got 1.6. So the first thing that we're going to say is that if you take y equals kx, and we are going to say, okay, if I have a direct variation, I should have, everything should stay constant. So my k, if I'm going to solve for that, I will divide both sides by x, and so k will equal y over x, and this should be the same for everything over here. Okay? So in each case, I'm going to take, my first one is 3.2 divided by -2. Okay? And then I have 2.4 divided by 1, and then I've got 1.6 divided by 4. Well, I mean, I can tell you already that that here I've got different things. If I put 1.6 divided by 4, I get a 0.4. Okay, here I've got 2.4. Here I've got you see that goes in there once and 12, yeah, negative 1.6. I'm kind of all over the place. So this is a no. This is not a direct variation. Let's look at another chart and see. So building another chart, you get to watch. Here I go. There's my X, my Y. And this time I've got 4, 8, and 10. 4, 8, and 10. And my Y is 6, 12, and 15. 6, 12, and 15. So first I've got 6 over 4. I'll go here. 6 over 4. I've got 12 over 8. And I've got 15 over 10. When I put 4 into 6, I get 1.5. I'm just going to do it that way, or 1.5. 1.5 probably looks better. Here 8 goes into 12 once with 4 over 8, or 1/2, so I've got 1.5. And 15 goes into 10 once with 5 over 10, which is 1/2, which is another 1.5. This is a direct variation. Okay, so I think that is enough information. There will be some word problems. You just kind of look at putting them into some functions. Let's look at one. It's a physics problem, and I've got a second. So we've got a start of it. Let's not look at that one because it's a two-parter. Let's see what we've got up here. We've got a recipe for a dozen corn muffins. Okay, so 12 corn muffins. I'm going to make 12 corn muffins, and it calls for 1 cup of flour. 1 cup of flour. The number of muffins varies directly with the amount of flour you use. Write a direct variation for the relationship between the number of cups of flour and the number of muffins. Okay, so if I get 12 corn muffins for every cup, then if I had 2 cups, that would equal 24. So I have, I'm working with some multiplication here. Y is going to equal, I'm going to, first of all, let's see equal the number of cups, okay, and I will get 12 times the 1 is 12, 12 times 2 is 24, so my equation is going to be y equals 12 times, well, I said x is c there, so I'm going to put, so we'll just keep it simple. I could have said 12c, but we'll just let x equal the number of cups. So y is equal to 12 cups. 12 is my constant, and so it's kind of easy to put these word problems together also. So that's it. I know, we haven't had much fun, sorry, but, you know, we can always have Mr. Googly Eyes, and he can help us a little bit. So hey, have fun with direct variation, okay?